Hey there, let's get into some math vocabulary before we get into some math problems. What do you say? First of all, I want you to take a look at this. This is an example or examples of things that you need to know before we get into what we're going to do later. Okay? You'll notice there are 4 words here, and they all are naming something that's on this board. The first word is the word term, right? Term. This whole thing, in fact, I'm going to circle it, is an example of a term. This right here. 3, the letter X, and this little 2 here, all put together, is an example of a term. Notice, just an example. There are different ones. The number could be different, the letter could be different, the little number could be different. But the point is, this is an example of what a term looks like in math. Okay? Now, the term has different parts to it. The first part you need to know is what this number 3 represents. You'll notice there's an arrow, and attached to the arrow is the word coefficient. This 3 is the coefficient of this term. A coefficient is a number that's in an algebraic term. Okay? Now you've got a letter of the alphabet. This is not the multiplication symbol. This is the letter X. And in this particular scenario, that letter X is called a variable. Now, variable just means that, the word variable comes from the word various, or variety, which means change, meaning the letter could always change. Things about the letter could change. But the point is, it's called a variable. And in this case, this example, it's an X. So far I've got 3 as a coefficient. X is the variable of this term. Now you'll see a tiny little number 2 with the word exponent pointing to it, with an arrow pointing to that 2, with the word exponent next to it. This little 2 is an example of an exponent. Now, what's an exponent? Well, an exponent is the number of times, or represents the number of times that I have to multiply a number. It's not what I multiply the number by, it's the number of times I multiply it. So, for example, this is a 2, okay? Let's say that I had a number 5, okay, a regular 5, with a 2. Little 2 is an exponent. What does that mean? That's not 5 times 2. That's 5 times 5. That's basically saying you're multiplying the number 5 twice. If I change that 2 to a 3, now I'm multiplying 5 3 times. So it's 5 times 5 times 5. You get the idea. But for this particular example, I don't want to get too far into the things, but in this particular example, this term is 3x. Now this 2 is called squared when you read it, squared. Squared, once again, means that you multiply the same number twice. So you read it as 3x squared. Not 3x2 or 3x second, it's 3x squared. Okay? And we'll get more into that in some other videos, but for now, that's what you need to know. Okay? So this is your vocabulary for what we're about to do. I'm going to pause the video. I'm going to write another word you're going to need to know, because then we're going to get into the math. Okay? Just hang on. Oh, by the way, pause this first. Copy this if you have to. Write it all down. Okay? All right, here we go. Okay, I'm back. And once again, to review, the terms that I've showed you so far, or the words that I've showed you so far, is term, coefficient, variable, and exponent, right? Well, now you're going to see how this all plays out in this next vocabulary word I'm about to show you. It's a big one. The word is polynomial. You could say a polynomial, right? And here's an example of a polynomial. What do you notice about it? Does anything about it look familiar to you? Well, yes. You see terms all over the place. How do you know they're terms? Because you see coefficients. You see variables. You even see an exponent here and an exponent there. Yes, a polynomial is an expression that has many terms because the first part of the word poly means many. Poly means many, right? So once again, a polynomial is an expression that has many terms, okay? And in this case, how many terms are there? Well, remember, the terms are separated by the signs, by the pluses and minuses. So there are 1, 2, 3, 4, 5, 6 terms in this polynomial. What we're going to do with this polynomial is we're going to simplify it. We're going to make it shorter because it's a lot of stuff there that doesn't need to be there, okay? Let me show you what I mean. Once you get that vocabulary down, and by the way, you could pause this to copy this down. You could even write the other words with it that we learned before with the examples. What you're going to do is we're going to simplify this with certain steps because it's way too long, and you know who wants that, right? So here is the polynomial, and I'm going to use the vocabulary that I showed you so far to help you get in the habit of knowing what the steps are. Okay, so I'm going to first look for like terms. Remember the word term, right? The term is the whole part. The whole part. It's basically each piece. How can I tell when something is a like term? When the variables are the same. What are the variables? The variables are the letters, remember? The variables are the letters. Now here's the catch. Even if the variable is the same, you cannot have like terms if one has one has an exponent and one does not. In other words, you could have 5x, and if the other number is 3x, or the other term is 3x squared, guess what? Even though the x's match, you can't use it. You can't do anything with it because that exponent changes everything. The exponent pretty much goes with the variable, okay? Let me show you what I mean. I'm starting with a 2x squared, right? Now I'm going to go down this polynomial till I find a matching partner, meaning another x squared. It doesn't matter what the big number is, what the coefficient is. All that matters is that the variable and the exponent, if they have one, match. So here I got 2x squared. Here I have a y, no match. Here I have a z, no match. Here I have a y, no match for the one we're looking for. Remember, we're here. Ah, what do you know? A 3x squared. There's my x squared. Do I have an x squared here? No. But this one and this one both match. Look, they match. They're happy, smiley face. See? Match and match. So I have to combine these. And the way I combine them is by paying attention to the sign that's in front of that second term. Now, because it's a plus sign, all I have to do is add this to this. Now, what do they both have in common? The x squared, so that stays the same. All you have to do is change the number. So you can add 2 plus 3. What's 2 plus 3? 5, right? And I just put the x squared next to it. And there you go. Okay? So these are done. Now I move on to the next term. I got a positive 5y. I'm looking for its matching partner. This is a z. Is it going to match? No. Ah, but there's a y. Negative 4y. We have a match. But notice it's a negative. So I have to subtract positive y minus 4. That's easy. That's what? That's 1, right? It's a positive 1. 5 minus 4 is positive 1. So I'm going to put a plus sign because it's positive. Now here's the good part. It's a 1. And in the world of algebra, when you have a 1, you really don't need the 1. That's redundant. You just need to put the variable that it is. You don't need the coefficient. So I'm just going to put a y And that's it. This is basically saying 1y, because 5y minus 4y is 1y, and I don't need the 1. That's redundant. That's a waste of ink. Okay? So these two match. They're done. Now, what do I have left? Well, I have a negative 3z, because these two are done, negative 3z, and I got to go all the way to the end to get a negative 2z. But they match because they both have a variable of z, right? So I just have to deal with the coefficients. I got a negative 3, and I got a negative 2. Well, if you're fluent in your negatives and positives, you know that negative 2 minus 2 is basically going lower. So the negative number gets larger, but it's still negative. It's a smaller number, but the digit itself is bigger, but it's lower because you're going more negative. You're going deeper into the negatives. So negative 3 minus 2 is negative 5, right? So I'm going to put a minus 5, and I keep the z, and there you go. Done. These match. Done. And there is my simplified expression by simplifying this polynomial, right? Okay. I'm going to pause the video. Oh, by the way, before I pause this video, you could copy this down. Now, when I come back, I'm going to write the terms again, and I'm going to give you a polynomial that you could try to simplify in your own time, and go back to the earlier parts of this video and see if it helps you figure out whether or not you got it right. Okay? Hang on. Okay, so here's the polynomial that I'd like you to simplify. And I tried to write all the vocabulary words without making it too sloppy so you could actually see what they are. Remember, this whole thing is a polynomial, the whole thing. Each one of these is a term. Now, I could have circled them all, but I didn't want to make it too confusing and block maybe accidentally block the pluses and minuses. But there are 5 terms here, right? Now, remember the parts. These little numbers you see are exponents. The letters are called the variables. Here's an example of one. Here's an example of one. There's an example of one. And the numbers that are next to them, the bigger numbers, are the coefficients. Here's an example of one right here. Here's another one. All of them have one, right? So once again, it's polynomial, terms, coefficients, variable, exponent. Go back if you need to remind yourself how to simplify these. Remember, you're looking for like terms. And pay attention to those positives and negatives, okay? I hope you found this video helpful. But before I sign off, I'll hold this up a little longer so you could copy it. You could always pause it too, don't forget. All right? Hopefully you can see it pretty well. Okay. That being said, I hope you found this helpful, and you could always leave a comment if you need help on the bottom there. And good luck. All right, see you later.